Okay, I've been asked to work a couple of problems from the Chapter 1 review homework. This is number 17. Now, all of us are going to have slightly different numbers because it adjusts for each and every one of us. But as I work these, your problem should be fundamentally the same, different numbers, but the same approach. Okay. So for this one, we're given this bar graph, and we're told that this represents the number of fatal crashes per 100 million miles driven for drivers of various age groups, okay? The number of fatal crashes is N, so that's right here, and the drivers are age X, so this will be the age. All right, so for the first part, according to the formula, what age groups are expected to be involved in 3 fatal crashes per 100 million miles driven? What this means for us is that our N has to equal 3. Okay, so what I'm going to do is I'm going to come up here and I'm going to write this and set it equal to 3. So I have 0.014x squared minus 1.21x plus 28.24 is equal to 3. Okay, so this is a quadratic, and to solve a quadratic I need a 0, so I'm going to subtract 3 from both sides right here, and I get 0.014x squared minus 1.21x plus 25.24 is equal to 0. Now, it could very well be that this thing factors, but I have these decimals. I don't particularly like them, so I'm going to go directly to the quadratic formula. So this is my A, this is my B, this is my C. X equals negative B, so that's going to be positive 1.21, plus or minus the square root of b squared, so negative 1.21 squared, minus 4 times a, which is 0.014, times c, which is 25.24. And this is all over 2 times a, which is 0.014. Okay, so I do the arithmetic in here, and I'm going to do this multiplication, and we find that x is equal to 1.21 plus or minus the square root of 0.05066, and this is over 0.028. Now we do have 2 answers here, and I went to my calculator, and you calculate it first using a plus here, and then second using a minus. And when you do that, you get the decimals. You get 51.25277773 and 35.17579413. Okay, that's what my calculator told me. We are asked to round to the nearest integer, and the nearest integer, in this case, my answers are 51 and 35. Okay, now the next part of this asks us, how well does the formula model, how good is it at representing our graph here? Okay, so what I look at is from this graph, it says 35-year-olds should expect to get in about 3 fatal accidents per 100 million miles. So that is exact there because we're supposed to have it 3. But the 51-year-olds, well, we don't have 51, but if you look here between 45 and 55, 3 fits comfortably right in between those. So how good is it at representing the actual data? It does a pretty good job. It does reasonably well. So that's number 17. The next one I was asked to work is number 30. Okay. And again, your numbers may be different, but fundamentally the same type of problem. Okay, so what does this graph represent? It is the percentage of jobs held by men and by women from 1970 through 2010. And they give you the formula that models the data, okay? Now from part A, use the appropriate graph to estimate the percentage of jobs in the labor force held by women in 2000. Give your estimation to the nearest percent. Okay, women are this red line right here. And in 2000, we are right here. In 2000 appears to be about halfway between 40 and 50%. So I say 45% is a reasonable reading from this graph right here. Okay, so for part B, use the mathematical model, which is the formula here, to determine the percentage of jobs in the labor force held by women in 2000. Round to the nearest 1/10%. So here we were using the graph to find the answer. Here they want us to use the model to find the answer, okay? All right, so 2000, well, I have P, which is the percentage, and T is the number of years after 1970. So if I'm talking about the year 2000, that is 30 years after 1970. So this would correlate with T equal to 30. So I'm going to plug 30 in for T right here. I get 2.5 times the square root, the percentage is, 2.5 times the square root of 30 plus 31.4. And all I've done is I've taken this T equal 30 and I plugged it into the formula we were given here. Okay? If you plug this into your calculator and get an approximation, you will get 45.093 and it continues. We are asked to round to the nearest 10th. Well, that would be the first decimal place, and that's a 9, so that goes up. So the answer they're looking for right here is 45.1%. Okay. Last part. According to the formula, when will 50% of jobs in the labor force be held by women? Round to the nearest year. Okay, well, P is the percent, and I'm wanting it to be 50. And this is our T right here in the original formula. So what I'm going to solve is 2.5 times the square root of T plus 31.4. I need this to equal 50% of all the jobs. Okay, now to solve this, I want to get the square root by itself. So first, I subtract 31.4 from both sides, and I get 2.5 times the square root of T is equal to 18.6. Now I want to divide both sides by a 2.5. So I get the square root of T is equal to 7.44. Now we need to square both sides. And you get T is equal to 55.3536. Now we're asked what year this happens in, and we know that our T represents the number of years after 1970. So if I take 1970 and I add 55.3536, I get 25.3536. And we're asked to round to the nearest whole number, so the answer they want here, since that's a 3, is 2025. And that would be the end of problem number 30 from the Chapter 1 homework review.